So, good morning, friends. I think if you've been following, say, the last 5 videos, maybe the last 8 videos, even if that's all you've seen, you may by now feel that it's very prosaic. In other words, there's not that not that big a deal here. The idea that we call this volume 3, okay, there's just that one innovation that the tetrahedron is one, and that seems kind of trivial. So, how trivial is it? I guess it's good to be in this position where we're asking that question and not this is, you have to be Einstein to understand this. No, it's more like anyone could get this. So, what's the big deal? Why do we care if it's so obvious? That kind of question. So, I just wanted to say a couple things about the coupler, and then I'll show you a codesters. 2 things. So we are in back to school season. So I've been talking about, where do we put this in the normal curriculum and why would we? It's not Common Core, obviously, but then neither is a lot of what's on YouTube Common Core. We have a lot of eclectic topics out here. You can put together your own curriculum and do pretty well. You can get a consultant to help you. But the question is, forget about esoteric homeschooling. What about just mainstream? How do we mainstream? I can get back to that, but the coupler, I'm taking 2 of the tips off that rhombic dodecahedron and sticking them together like this. I've referred to this before as the coupler. I've got a web page on it and so on. And I'm like the only YouTube channel probably using that terminology or really drawing much attention to this shape. Outside of synergetics, it's not really given a name special, but notice it is a space filler. Because why? Because rhombic dodecahedra are, and this is just a piece of that assembly. This is just the part poking in to the center of, say, a black cube, and the part poking out, say, to the center of a white cube, where one set is occupied by balls that communicate or touch or intertangent through the cube mid-edges. And this is our cube from quite a while ago. Remember our cube with the edges square root of 2 and the face diagonal of 2. Face diagonal of 2. And that's what's unusual or different about this Bucky geometry, is that this diagonal of 2 radii, 2 sphere radii, because spheres would touch through there, gives us an internal tetrahedron inside of this. You saw me bumble through this the other day, especially the second row. I really put a lot of corrections in the thought balloons. If you were watching and not just listening, I used the video track to say, wait a minute, I'm making all kinds of mistakes going across this. And you think, so I have my bad days. I thought I would just leave it in that, I'm not the only one who can teach this stuff. So let's get a lot more about the coupler out there this year if we can. Remember, you've got your colors to choose from, I guess. So codesters, see if I'm still logged in. I've got the 2 rhombuses that, I call it the Genesis story. What do I mean by that? So, like, I have this big poster here. I'm going to take it in front of the window right now to block the sun. Keep dropping things now. So all it is it's polyhedra. It's a big poster. I took one of these to Bhutan, as I recall, by www.peta.com. I don't even know if they're still in business at the moment. I don't know that. So it's just, okay, so that was a picture of, it's got the Platonic solids, the Archimedean solids, the prisms and antiprisms, and Johnson solids. Okay, so that's a pretty interesting poster. So the 5 Platonics is where I start my Genesis story, but if you think about it, since the tetrahedron is self-dual, The tetrahedron generates the cube, and the cube, you could say, duals into the octahedron. And then from the octahedron, you could jitterbug open to the icosahedron and get the pentagonal dodecahedron as its dual. So there's a different like hypertune scenario through all this. It's not doctrinaire Genesis story. 5 platonics is where we start. But we could. It's a good, useful beginning. And there are many ways to write curriculum. I'm just saying we could have a bonanza of people needing, we need a lot of people to help here phase this stuff in. If you accept that this is worthy material, then let's phase it in, and hey, that's jobs. People should be happy about this. It's just all kinds of curriculum needs to be redone, and I'm giving you plenty of ideas, but hey, I can't do it all, can I? So let's run this. What it's going to give us are the two rhombuses that we get from our Genesis story. That's the one from the outer one. You don't have to say these are to scale, because it's more like I want you to see the differences in the angle, and then you can resize them at will around the same center if you want. But the outer one is the rhombic dodecahedron, so I'm talking about, once again, not this angle, but okay, so I'm talking about this shape here. So let me get an actual cube inside to get the angles right. Okay, so back, it's all disassembled now, my thing. So, but it's fun, see, to just put it all back together. So there's the corner of a cube, 90, 90, 90. By the way, Descartes' deficit's going to fit in here. Another topic to look up, well known in math, but part of the curriculum fits right here. The number of degrees you'd have to add to each of these vertices to open the thing up and make it all flat. You could think of it that way. More, think of it, how much curvature did we have to take away? How many degrees did we have to subtract from any of these polyhedra to get a nice convexity? Convexity, concavity, something that totally connects around. What did we have to do? So now I have the two cubes, right? 3 plus 3 equals 6. And I'm going to cannibalize cube number 2 to put the half couplers back. So couplers are space filling and unit volume. Unit volume in synergetics. Again, so simple, so easy. You're thinking anyone could teach this. It's not a big deal, so why aren't we? Exactly. You're thinking on my wavelength now. So these all have a volume of 1/2, these half couplers. So that's what I've been reconstructing there. The face of a rhombic dodecahedron, that diamond. Now that diamond is what you see here in Codesters. And then the inner diamond is what you'd see on the face of an E module. It's a phi or T module. It's a phi, either one. It's 1 by phi. In other words, the longer one is 1.618 longer than the shorter one is supposed to be. And the math is over here, or let's call it the, what I do in this is, as I bop the turtle, let's see, how do I do this? I make the turtle just do the crisscross, and then I memorize the 4 points, and then I send another turtle around in the right order to draw the rhombus. So that's the logic of what goes on over here. If you don't understand what the star does in front of these letters are tuples, coordinates, like a pair of numbers with a comma in between. Goto expects 2 separate arguments, and what the star in front does is it, quote, explodes or scatters the content of the tuple from being one object, a tuple, to being 2 separate objects, 2 integers, or 2, in this case they will be integers because they're the screen coordinates of our shapes, which are what? Integers. That's the domain that we have for doing turtle graphics. Okay, so to summarize, It's back to school time. You can stay home and watch about UFOs if you're lucky and have a custom curriculum. Everyone's put something together for you. You don't even go to school. But say you do go to school, help us think through how we're going to phase this in and think outside the box in terms of this could be your English class because you're developing fluency around shapes, and that's just generic language abilities in a way. It's just very generic linguistic skills. So, and because Fuller's a poet, and all of the map of the graphing the poets, one of my essays, the Pound era comes through these YouTubes. In other words, there's a lot of literature packed into these YouTubes, but that's just to indicate where we are in general. We're in the humanities here. And so I know it makes sense that this should all be in your math class, but that's one of the more difficult places to make change. And in terms of being literate about your recent history, what's been going on the planet, who's been here saying what, it's much easier to talk about Buckminster Fuller in those terms, and actually make use of that movie, House of Tomorrow, on DVD or Netflix, stream it, see what I'm talking about. Because there's a segue to lots of music there, and I've been exploring that as well. Okay, so it's all very clear and obvious now, isn't it? The main difference is that cube in ordinary XYZ math, because the edge is square root of 2, there's no way this thing could have a volume of 3. Right? So that's what. Go back and watch the earlier YouTubes if interested, and get into it through that door. You'll find there's a whole playlist called Synergetics 101, which is more the hard edge sort of static stuff that's not spinning, not spherical, not curvilinear. And then Synergetics 200, I believe, is more, I'm going off college course kind of stereotype names. So that's already here. And what you're watching now is sort of a roll through 2019 trying to build up some steam on this terminology, because a lot of it is terminology: A module, B module, coupler. Where and when do we get this in school? And I'm suggesting English class or language class, because you're coupling your visual imagination, your ability to conjure shapes and to think geometrically, spatially. You're connecting that to being able to talk about it as well. And this is just generically useful. Um, and you can look at it as communications. All right, we'll stop there for now. Have a good one.